Howdy. Some days ago, I've been outside and I heard an airplane. I didn't see it, but it sounded like a small one. And since there's an airport, or an airfield maybe, not too far away from here, it's not something very special that you hear some airplanes. But since I'm a curious person, I checked out the flight radar application and there was an airplane flying, which belongs to Bloom Geomatics. And they have been flying over Finland like since I think several years. Every now and then they come around and take pictures of stuff. And so I followed the airplane where it flew, and it turned out here it's not visible on that picture, but it made a turn that it can go here or flies over that area, which is the plasma rock site. And it flew over it. Maybe they don't know, but the craters are like the one very, very, very interesting crater is here. Now they know. And since it flew rather slowly, it took a while, but it flew here back and forth. It made this kind of turns to the left and right. And it flew once again, obviously, over the plasma rock side. This might be all very coincidental, but the plane left from Kuopio. So let me show you what's in Kuopio. Kuopio. I actually pushed the wrong button, so that's why you have to travel with me to Kuopio. This is how it looks. There's like water everywhere. Yeah, it's Finland after all. 180,000 lakes or something. And there is a rather large hill there. Yeah, anyway, now we have seen it, doesn't change anymore that much, but let's put off the pictures, probably we don't need them. Because, maybe it's somewhere here. Do we have everything turned on? No, once again. Why? I think it's somewhere here. No. Hospital? University? GTK. The Finnish Geological Survey. Yeah, maybe you need to go around there once to visit. Check it out what they have. They have a bunch of stuff there. Gold. Zinc, copper, rikki. Isn't rikki sulfur? Yeah. You know, English isn't my mother's tongue, nor is Finnish, so I have to check out and verify every now and then things. And I thought that rikki, yeah, it might be sulfur. It has many other meanings, but sulfur, brimstone. Wow! You know that I have been playing around with my microwave and stone and found sulfur in those and figured out that somehow copper and sulfur belong together. For whatever reasons, no one could tell me yet. If you know it, why tell me? And now we have also zinc. Very interesting. But anyway, GTK. And since the plane left from Kuopio, where we found just the GTK, and I think it's one of the bigger facilities they have in Finland, maybe the biggest, I'm not sure. Maybe in Helsinki is a bigger one, but the Kuopio place is very important for them. There's like mines and stuff in the vicinity. But anyway, then we have this plane which flies around and makes maps, and it flies over the plasma rock site twice. Bloom geomatics. So this is a site I found about Bloom geomatics, or Blom. Somehow it's related to Bloomberg. Bloom or Blom Geomatics AS provides comprehensive mapping and photography services. The company markets its services to commercial photographers, map makers, public institutions, urban planning professionals, and other commercial customers throughout Norway and internationally. Technology, economics, politics. Somehow that's rather confusing. Opinion. City Lab. Why is this somehow related to that US edition? Maybe we have to check some other Blom geomatics page. Yeah, I don't know. It's rather hard to find something. I once found some page, but now it's, I don't know. Reviews, that's just what you get from Googling that. You get the directions and call them. Located in Norwegian Space Center. Very interesting. Let's click on the Norwegian Space Center. It's closed. Oh no. Wheelchair accessible car park. Okay. But we don't do too much with this information. Obviously. Here is another link. Plum-kartta. Keräämme ja jalostamme tarvitsemansa paikkatiedot. Asiakasryhmille meidän suunniteltuilta sivuilta löydät kootuna juuri sinua kiinnostavat ratkaisut. Yeah, that's Finnish. So let's translate it. We collect and process the location data you need. On the page is aimed at our customer groups. You will find the solutions that interest you. Electricity transmission and energy. Terrain models of tunnel projects. Maps, 3D city models, Bloom Street View photos producing forest resource information. Yeah, maybe I have to write them. Do you have a picture for me? But anyway, because they flew over the plasma rock site, as I call it. Officially it's called Kuhasalo or Kukkosensaari. And the thing is, I have been writing about that place. In my paper, Plate Tectonic Issues, the Influence of Electricity in Rock Forming Processes and the Coherent Connection Between Science, Mythology and History of Finland. The Sea Pinch Stone and the Dragon. You scroll down a bit. Geological issues, Finland. Plate tectonics, whatever map of tectonic plates you watch, you won't find any tectonic lines in Finland. Just an example here. Take a geological map of Finland and you will briefly discover that there are four main tectonic domains in Finland: Kola domain, Karelian domain, Svekofenian origin, and the Rapakivi granite Jotnian sedimentary domain. When looking even closer, you will notice that it is basically a huge mess with intrusions, veins, bow-shaped forms, and all kinds of things in and on the ground. In 2019, a geological paper was published with the title Paleoproterozoic Metamorphism in Northern Fennoscandian Shield, Age Constraints Revealed by Monazite. Like the title already revealing, something doesn't quite match up in Finnish tectonics. The conclusions section contains also interesting statements. For example, low pressure, high temperature metamorphism and almost total lack of medium PT rocks in the Svekofenia province refers rather to accretionary than collisional processes. And therefore the tectonic evolution of the Svekofenian origin from the metamorphic point of view remains still largely an open question. Low pressure, high temperature metamorphism. Since I wrote this paper and read a bunch of other things, made my own research about, I'm doing research all the time about dozens of things basically simultaneously because some things just pop up. And sometimes you are searching for something and you don't find anything. Sometimes you are searching for something and you find something else which is related to something else you were making research about, and so it's not a straight line of figuring stuff out which just goes in one direction because it's spreading all over the place. But anyway, since I wrote that article some time ago, 2021 at the end, 2000, back then, when I wrote it, and now low pressure, high temperature metamorphism, I came to think about the possibility that this could probably sound as the aurora borealis would have touched the ground. Low pressure, high temperature, which would be maybe different to when we would have something like very heavy lightning strikes. There we would have also very high pressure. You know? That's maybe the difference. That's maybe the key. I don't refer to their paper. And since they're writing this, low pressure, high temperature metamorphism. And later remains still largely an open question. So, here are some maps from that paper, and the plasma rocks are somewhere here, I think. Sulkava. Yeah, it's really hard because there are no real marks here. Here it says Outokumpu, but there's no arrow or whatever marks. So in a way, I don't know if that cross maybe is Outokumpu. I don't know. A simplified geological map of Finland showing the province division by Nironen. So blue paleoproterozoic subcrustal and infracrustal rocks, whatever that means. Another map, metamorphic map of the proterozoic bedrock of Finland. Once again, there are no really marks. You cannot really grasp what is where exactly. But I would claim that the plasma rock site is somewhere in this area. So we have different kinds of things going on here as well. And on the third map, it's just repeating. Maybe I have to figure out about these numbers. Uranium and what is it? Lead ages of monazite on the metamorphic map of Finland. Yeah, there's an old abandoned uranium mine not too far from here. You know, I know. They know that I know. They also know that I know that they don't know. Here I talk a little bit about peat. And I still wanted to show you this here. Here I talk more or less about lightning strikes. Maybe nowadays I probably tend to think it might be auroras and not lightning strikes. Oh, there was lightning strikes too. But I think I really have to include also the aurora borealis touching the ground and burning stuff. Because they are very hot. I don't know how they would react if they really would touch the ground. Would they stay hot as they are up there? Would they cool down? Would they get even hotter? And as we know, energy goes both ways, as I have been talking about volcanoes and mountains, cryptodomes, which are volcanoes, source domes, like, a mountain where we have water pouring out, with those clouds which are rising up to the sky. And if there would be aurora borealis touching the ground, would there like stuff rise up from the ground, like stuff what you could see? Would there be wind going upwards? Because there would be maybe a crack in Earth's magnetic field. I don't know who to ask. So this is stuff I ponder about in my spare time, which is not. I don't have any spare time. Wherever you look, whatever you do, you will see repetitive patterns and stuff like that. So these are now pictures, actually, now I forgot, from the plasma rock side. And these are just a very few. Maybe some recognize the one on the left. Molten metal on top of rocks. Magnetic anomalies. We have this surface conductivity anomaly here in Finland. And as marked, we have the plasma rocks, where you also find an old abandoned copper mine. And Outokumpu, not too far from here, where we have quite much mining operation. It has been a mining town. It has been the third most important copper mining facility in Europe once, back in the days. So there is a lot of copper, or has been. And copper is very conductive. And there is sulfur in those rocks where we find copper. So not all sulfur you'll find is probably volcanic in origin. This is something I just learned recently, or noticed, or whatever, and since then I'm very interested into sulfur and stuff like that. Now you probably understand the sulfur excitation at the beginning of the video. There's like all kinds of very interesting features there. We would be in the Peterson and Hall currents, so from the Bertrand current. And let me show you still one picture, because this has brought to an end. That's already very too long, this video, I think. That's the same picture you just saw. I just marked other things, because at the 8th of August last year, we had auroras. I think I made videos about these. You will find them here in the backyard, or probably above. Fortunately, Surprise geomagnetic storm, a solar wind stream hit Earth's magnetic field on August 7th. At first, the stream's velocity was low, but during the day it sped up to more than 600 kilometers per second, ultimately triggering a G2 class moderately strong geomagnetic storm. This event was not in the forecast, so the resulting auroras came as a surprise. And I think it even turned out that there was a crack in Earth's magnetic field. And also somehow the direction of how it is aligned, these polar lights, they go with the direction of this here, of the interface, of the polarity interface of this surface conductivity anomaly. And way outside where we have the magnetosphere, sorry I couldn't stop, I just still have to show you this. The polar cusp reconnection, where the Burton current goes upwards, but the magnetic field forms its torus shape. So the globe with the electric circuitry and stuff, but here we don't have this. The polar cusps, but let's check just this picture. That's the polar cusp. The torus. Yeah, actually now I found a better one. Polar cusp. So, that's an observation of the polar cusp, how it looks with the polarities and stuff. And I would say the surface conductivity anomaly has somewhat quite similar shapes, similar patterns. Of course, it's not perfect. So the possibility that if you think this polar cusp region would have come down and touched the ground, I bet there would have been northern lights, you know. And maybe it came down and imprinted once on Earth's crust these patterns, which are nowadays influencing the weather, local weather patterns very much because of their polarity. Here we have the Kursk magnetic anomaly. And if you watch the weather maps, there's a high pressure system there. Since Earth's magnetosphere or magnetic field is weakening, these kind of features in Earth's crust, they will influence more and more the local weather patterns. Like some scientists noticed this some time ago in Germany, that back in the days, like there were like storms just blowing over the land. Nowadays they are just stuck in place for whatever reason. And I think I heard the same thing from America as well. Someone was wondering how is it possible they just don't move anymore. Yeah, because the magnetic field gets weaker and these kind of things, the imprints in Earth's crust, they have more and more and more influence. Of course, until it goes the other way around once again. But anyway, I think I leave it here. Some airplane talk. Thanks. Bye.